This module is about rational equations. So first, let's take a look at the given graph for a rational equation. So this one right here, they want you to write the equation for our vertical and horizontal asymptote. Make sure when you write equation, make sure you put x equals something and y equals something. I've noticed that a lot of students just simply put down the number, and you don't want that. If you just simply put down the number, that means nothing. So equation means you have to have the equal sign in there. All right, so let's take care of vertical asymptote, which is this line right here. So it's crossing 5. So the vertical asymptote is going to be x equals 5. Horizontal, you can see right here, is the x-axis, which is y equals 0. The domain and the range. So domain, you look from left to right, and you see right here, and then we go right here. So make sure that you notice the gap. So the asymptote means the graph approaching that line but never touch that line. So we do have a gap right there for the domain. So let's just write down the domain. The domain is going to be from negative infinity, and you see where the line, that's going to be x equals 5. So it's going to stop at 5. And like I said, we are not allowed to cross or even touch that that line, so we have to use parentheses. For the range, you can see that it's approached from negative infinity, and then it stops at 0, which is a horizontal asymptote. Now the x-intercept are the one that crosses the x-axis. Y-intercepts where the one crosses the y-axis. In this case, you see that the graph does not cross the x-axis, so we have none x-intercept. For the y-intercept, we have this point right here. That would be -1. Okay, so hopefully you know how to read the graph. All right, moving on. We want to graph all the vertical and horizontal. Let's talk about vertical. So for vertical, you take the bottom, you set it equal to 0, and you solve it. So in this case, x is 1. All right, now if you have a constant on top and a linear on the bottom, so you can look at the degree. So the degree on the bottom is 1. The degree on top is 0. That means the horizontal asymptote is going to be y equals 0. Which is the x-axis. Okay, so every time the degree of the numerator is less than the degree of the denominator, we have y equals 0 as a horizontal asymptote. Let's take a look at number 3. Number 3, like I said earlier, so for vertical, you just take the numerator, the denominator, and you set it equal to 0, and you solve it. So in this case, it's going to be x equals 5/2. For horizontal, you see the degree is 1. For numerator, degree is 1 for the denominator. If we have the same degree for top and bottom, you simply pick the coefficient, and that's going to be the horizontal asymptote. So in this case, it's going to be y equals 1/2, 2/4, which is 1/2. All right, so I repeat, every time we have the same degree for top and bottom, we simply pick the coefficient of the highest degree. Okay. All right, moving on to number 4. So for number 4 right here, vertical. So let's take care of vertical. I take negative 2x squared plus 2 equals 0. So it's going to be negative 2x squared equals to negative 2. So x squared equals 1. You take the square root, you're going to end up with plus and minus 1. So we do have two vertical asymptote, which is x equals 1 and x equals negative 1. Now, we check the degree of the top is 1, degree of bottom is 2, so the top is less than the bottom. So for horizontal is simply y equals 0. Okay, moving on to number 5. So number 5 right here, vertical, you can see it's just x equals 2. So x equals 2, that's the vertical. For horizontal, so we have the degree right here is 2, degree right here is 1. Every time the degree for the bottom is 1 less than the degree in the numerator, we have something called a slant asymptote or oblique asymptote, so it's not horizontal. We simply take the top and divide the bottom. So I can do long division for this one. So if I do the long division, negative x squared plus 2x plus 3, and I have negative 4 plus 8. I subtract, so I get 3 minus 8, so it's negative 5. Anyway, my only concern is that, and that's gonna be the oblique asymptote. Is y equals negative x minus 4. You see it's a linear equation, so it's a straight line. However, it's not horizontal, it's not vertical, it's slant. So that's what we call the slant asymptote. All right, so number 6, we have to graph the rational function. So in order for us to graph the rational function, we need to find the asymptote. So in this case, the vertical, you can see vertical is going to be x plus 4 equals 0. So it's going to be x equals negative 4. And then horizontal, you see that the top is 0 for the degree, the bottom is 1. So it's less than the bottom. So horizontal is going to be y equals 0. So first, let's just graph our asymptote. So we have negative 4 right here. And we have the x-axis for horizontal. Okay, and then you can simply, you can definitely try to solve for the y-intercept, because the y-intercept, you just let x equal to 0. So when x equal to 0, f of 0 is just 1. So you can see that the y-intercept is right here. Okay, you can definitely pick 2 more and plug in the equation. So you can pick negative 2 or you can pick negative 3. I'm going to pick negative 3 and plug it in. So f of negative 3 is going to give me 4 over negative 3 plus 4, which is 4. So negative 3, we have 4, so it's right here. Okay, And then we can pick somewhere around, here. Okay, so I'm going to pick -6. So f of -6 is going to be 4. Usually I tend to pick something that would give me a whole number. So that's the whole point of picking these points. So I have -2 for -6. -6, -2 is right here. Okay. We can pick -5. So pretty much this is just making table. Is -4. So -5 for x is going to give you -4 for y. Okay, I think I'm ready to graph. So remember, not approaching the asymptote, but not touching. All right. Okay, moving on to number 7. So number 7, once again, I'm gonna take care of vertical. So vertical, you can see right there, is gonna be, for vertical is gonna be x equals 2. For horizontal, okay, so for horizontal, you see that we have x on top, x on bottom. So we simply take the coefficient, which is 3 over -1. So that's just -3. So the horizontal asymptote is y equals to -3. All right, I'm going to try to draw the vertical and horizontal first. So this is vertical. And this is horizontal. And then we simply pick points. So once again, you can always take the, we can always try the intercept. So when x equal to 0, we get -3/2. When you can definitely put y equal to 0 and try to solve for x, or we can just randomly pick some point. How about when x equals 1? When x equals 1, that's when y equal to 0. Let's say when x equals to 3. When x equals 3, y is going to be 3 times 3 minus 3. On the bottom, we have -3 plus 2. So it's going to be 6. -6. Okay, so I have a point right here. I have a point right here. I have a point right here. Okay, I think we are ready to graph our function. So we have this approaching the asymptote. We have this one approaching the asymptote. For number 9, to graph the rational function, I'm just going to try to find the asymptote first. So for vertical, we have x equals to -1. By now, you need to know how to find the vertical asymptote and the horizontal and slant. You see that right here, we do not have horizontal because we have x squared here and we have x on the bottom. So that's one less than the top. So we have slant asymptote instead. So for the slant asymptote, you're going to have to divide. So I'm going to take negative x squared minus 4x plus 4, and I'm going to divide by x plus 1. So when we subtract, we get negative 4x plus 1x. So negative 3x plus 4. Negative 3. So we get negative 3x here, negative 3. And when I subtract, I get 7. Okay, so for the slant, is y equals to negative x minus 3. So let's draw the asymptote first. So for x equals 1, we have the vertical right here. Now for the slant, it's going to be negative 3, and then we go down 1 to the right 1. So I have, okay, so this is my slant asymptote. Okay, now you can definitely try to find the x and the y-intercept, and then you can just choose some point to make a table. So if I pick x to be 0, I can see that y equals to 4. When x, let's say when x equals to, how about we cannot pick x equals 1. So I can try x equals 3, negative 3. Because we do want to try somewhere right here and somewhere right here. So I'm going to pick negative 3. So if I have negative 3, it's going to be negative 9 plus 12 plus 4 over negative 2. So it's going to be 7 over negative 2. Okay, so that's negative 3. 3.5. So negative 3.5. Okay, so we have negative 3 and negative 3.5 is right here. So I have this point. I have 0, 4, which is right here. Okay, I think I can guess. So if I try negative 2, let's try negative 2. We're going to end up with negative 4 here. Plus 8 plus 4, which is 8. Okay, so for negative 2, we get 8. And then divide by negative 2 plus 1, so divide by negative 1. So for negative 2, we get negative 8. Okay, so it's right here. So the graph is gonna be like this. You definitely can try more point, but based on the asymptote, we can tell the graph is going to be like this because it's approaching the asymptote. All right, moving on to number 10. Okay, so number 10, once again, I'm going to look for the vertical asymptote. But you can see right here we have negative 3x. So I'm going to factor negative 3 out. So I'm going to get x plus 4. And then on the bottom, we have x plus 1 and x plus 4. Okay, so if you simplify it like this, you see that now the vertical asymptote is just x. The vertical is just x equals to negative 1. All right, so let's just, and because we have x here, we have x squared here, so the horizontal asymptote is going to be y equals 0. Okay, so that's something I know. Right here, and we're not allowed to touch that. Okay, now even though we simplify the x plus 4, but you have to understand that at x equal to 0, as x equals to negative 1 and x equals to negative 4, we have problems, because if you use those 2 points, you're going to get 0 on the bottom. So we're going to have to exclude that number. So when x equals to negative 4, what is g of negative 4? And we have to solve for it. Okay, so g of negative 4 is going to be 1. All right, so at that point, we're going to have a hole. So it's going to be right here. Negative 4, 1. So we have to keep it that way. So you can see that this one is just like the typical rational function, but we have over here and we have over here. You can definitely pick some point to see if we have the point here, the point here. If we have something here, we have something here. If we have this one right here, this one right here. But then you see that we have the hole right there, so I know it's going to be on that side. So I can just draw.